Hello there, and welcome to this mathematics class presented to you by O3 Schools JAMB app. You can see the name on the video here. O3 Schools JAMB app is an application which you can install in your phone or your laptops. And what it does for you is that it gives you access to a mock exam software that is designed to simulate your actual JAMB conditions. That simply means that once you install this app, you can actually look through and set your exam. You pick your subjects, you can set the time, and you can try to set this to the mock exam format such that you can actually feel as though you're writing jam and they're actually able to get a good measure on what you know and actually how long it takes you to solve questions. Because as you're aware, jam is not all about saying you know the answers. You have to have speed and accuracy, know the answers, and also work fast so you can finish within the allocated time. So with your two schools jam app and its mock exam feature, you can do that and test yourself. And as you're aware, practice makes perfect. The more you do, the better you shall be. And you can be able to see that on that day, you'll perform extremely well and without stress because you are used to this scenario. You've tried it out several times. There are also other features included in this app. It gives you a lot of information, the different courses offered by different schools. Those of you watching who have enrolled this year's JAM, well, you may have seen it already, but if you want to get more information, you can see it has the different schools within the country and the different courses offered by those schools, and even the subjects required to be able to study those courses in whatever institution you are picking. So the O3 Schools Jam actually has a lot of wonderful features which are all available to you. Once you download the app, install it, and then activate it. Yes, you have to activate the app. The activation simply costs 2,500 naira only. 2,500 naira only, nothing more, just 2,500 naira. You can activate your app and be able to enjoy the full access to all the features which this application has to offer. It makes your life so easy. There is my personal favorite, the question search feature, in which after reading any topic, you can simply open your JAMB app and search for the questions pertaining to that topic. So that as you read the topic, you answer, read the topic, you answer. And you find that that's very pretty much or pretty soon, you have covered pretty much all the questions JAMB has to ask you. And next time you see these questions, it will be like repetition because you have seen them before and you are quite good at answering these questions. So get your three schools JAMB app, install, activate, and we shall be ready to proceed with this mathematics class. And in this class, we shall be looking at change of subjects formula. Now, this is a topic which is actually one of the most versatile in mathematics. Like right after learning plus, minus, times, and divide, the next most important thing you need to know in mathematics is actually change of subject of formula. Why is that? Because in every single equation you can find in mathematics, once you have an equation, you're always looking for something. And that thing you're looking for has to be alone on one side of your equality. Say, for example, you have 5 plus x equals to 10. Now, as you are aware, you want to find x. For you to find x, you cannot be having 5 here with it. No, this 5 has to leave it. And we already know pretty easily that this must be x equals to 10 minus 5 and x equals 5. Change of subject formula is pretty much exactly this. Only difference is that in this topic, most times we are working with letters. Now, say you are solving a question and you have your formula as let's say 2k minus p equals to square root of s over 2. Now the problem becomes, what if what you want to find in this question is k? Should you just put in all your figures for s and for p and start solving for k? While yes, that is possible, at times the numbers are big and cumbersome and difficult to work with. You realize that the easiest way to work with it is simply to make this k equals to something, so that everything you are putting in will be on one side of your equality, and what you want to find will be alone over here. So I want you to simply press whatever you have into your calculator. You are done. Your answer comes out straight. That's what this topic is all about. How can you make something stay alone on one side of the equality? And then at times, this thing may be alone. You may be having some funny things with it. Say, for example, x cubed equals to 20, or let's go with 125. In that case, what do? You want to find x, not x cubed. That means this cube has to go. So please note, if you ever have a power attached to a letter, to get rid of that power, you have to find the root of that number, but the root should be to whatever the power is. That means if the power here is 3, I should find cube root. If the power was 4, I would find fourth root. And if the power is 2, obviously, I find square root. So you see, to cancel power, you have to find the root of that expression. And remember, in mathematics, anything to the left must also be done to the right. That means I also find the cube root of that side. So you see, that's just how it works. And in the same way, if I was having cube roots attached to it already, then I do the exact opposite. To get rid of cube roots, I have to simply cube both sides, because cube will always cancel cube roots, just like it did over here. So you see, first thing you must do, try and shift everything you can shift to the other side. If there's a coefficient, divide by the coefficient, and if there's a power, get rid of it. If there's a root, do the same thing. So that is simply how this topic works. And now the easiest way to show you how we can solve questions is actually by solving questions. So we simply have to open our O3 Schools JAMB app, and we're going to solve a couple questions so you can see the general method when dealing with change of subject formula. So let's just wipe the board and open our O3 Schools JAMB application. All right. So once you open, our first question we shall attempt comes from the year 1997. Comes from the year 1997, and that is question number 12. 1997, number 12. This one says, make F the subject of formula. Make F the subject of formula. I want to make F the subject of formula. Given that T equals the square root of V over 1 over F plus 1 over G. So we want to make F the subject of this formula. That means we want to turn this into F equals something. Now looking at it, first of all, I cannot touch this my F yet because there's a square root covering it. Like I just said, how do you get rid of a square root? There's a square root. To remove it, you have to square both sides, such that this square removes my square root. So I'll be having t squared equals v all over 1 over f plus 1 over g. Now once I have this, I look at it and I'm like, okay, next up, I really need to have f equals to right. That means I must take this my f to the left. How do I do that? Cross multiply. T squared will multiply everything here. So t squared times 1 over f plus 1 over g. And this would be equal to v. Progress has been made. What can we do next? Now again, remember, I want to separate f from every other thing. So how do I get f separate? Open this bracket. T squared times 1 over f will give me t squared over f. Then t squared times 1 over g gives me t squared over g. And this is equals to v. I notice we've made progress. Now we have f, but the thing that's attached to f now is this t squared. So, first of all, this thing that has been added to it, let's remove it. Take t squared over g to the right. That leaves me with t squared over f equals v, then taking plus to the right becomes minus t squared over g. You see, very, very easy. We've made progress. We're having t squared over f on one side. Remember, I want to find f, right? So how can I begin to make this f stand alone? Well, one easy way I see right now is asking myself, okay, let's do a bit of solving on this guy first. So we have everything over one thing. That means t squared over f was, what's the LCM of this? G and 1. LCM is g. G divided by 1 is 1. G times v is gv. Minus g divided by g is 1. 1 times t squared is t squared. And if you're wondering why we did this simple answer is because once I've done this, I can cross multiply again. Remember, our aim is still to leave f on the left. So what do? F remains here, but f is now multiplying gv minus t squared. And once we do this, you realize that this t squared that was the numerator would leave. It becomes t squared times g, t squared g. Or if you prefer, gt squared. Most times in mathematics, we like writing it in alphabetical order. G comes before t, so gt squared. And once you've done this, you realize I am almost done. My f is now alone, but it's multiplying something. So remove this thing is multiplying. This is gv minus t squared over gv minus t squared. This cancels this. And so now f is all alone, and it is equal to gt squared over gv minus t squared. Is that in our options? Yes, that is option B. So, as you can see, this is how it always works. It may seem a little bit longer, cumbersome, but we simply followed many different procedures to get here. But keep in mind, throughout the solving, your aim is always to get your f to remain on your left. Notice, as soon as we got the f to the left, we never removed it from the left again. Other things may come and join it and then leave, but the f did not leave the left hand side. We kept on trying to make sure it was the only thing remaining there. And once you do that, you are all done. So how do you see the methods? Just simple, if you want to call it in a phone name, ring around the rosy. Simply move everything around until f is left alone and every other letters or numbers have simply moved to the other side. Let's try another one. This time we go to 1998, question 11. 1998, question number 11. And this one simply says, make a over x. That means now we're not making just one letter. We're making actually one letter over another. We want to make it remain on one side where that thing should move. So make a over x the subject of formula. And the formula was x plus a over x minus a equals to m. Now I want to make it a over x equals something. Now how do we go through with that? Let's just erase this to avoid mixing both up. So we want to have a over x, a over x. Now no a must be the only numerator, right? And we cannot do that while it is adding to something else. So let's first of all simply cross multiply. It's a very, very easy first step. M will multiply this. M times x minus a equals x plus a times 1 x plus a. First step done. Anything we could do next? Yes. Open this bracket. Mx minus ma equals to x plus a. Now you notice in order to have a over something, I have to take every single element a to one side. So I'm having ma here, I'm having a here. This a has to come and make it over here. I will have minus ma. This a comes to the left, minus a equals x. Then this mx cannot remain here either. It has to move. So plus mx goes there and becomes minus mx. You see, now all my letters with a are on the left. However, a is common here, a is common here. So I can factorize a out. A comes out, and I'm left with minus m minus 1. Is that agreed? Because remove a from minus ma, a separates, minus m is remaining. Remove a from minus a over a is 1. This is equals to x minus mx. So to make this a remain here alone, over minus m minus 1 over minus m minus 1. So a equals to x minus mx over. Now, a fun way to actually deal with this denominator is by saying, if you bring out minus, you have minus leaves m becomes plus m, minus leaves minus 1 also becomes plus 1. Now we're almost done, right? We have a. But if you remember in the question, just finding a was not the question. Just finding a was it, would be done. Instead, I want us to find a over x. That means I have to have over x there. So a over x. That means I'm dividing both sides by x. Before I do this though, let's try something here to make x enter one place. Because here is x minus mx. But if I factorize, I will have x, open bracket, 1 minus m, all over minus, open bracket, m plus 1. See? So now that x is outside, I can now say divide both sides. Remember, in your exam, OBJ, you don't have to write this. This is just so I can see what I'm doing. Divide both sides by x. So a over x equals to x into 1 minus m over minus m plus 1 divided by x. Now, quite simply, if I'm dividing both sides by x, write it properly. This is x into 1 minus m over minus into m plus 1. Divide means times 1 over x. So x cancels x. And therefore, a over x must be 1 minus m over minus into m plus 1. Now, here's where maths gets interesting. Anytime you have a question to simplify, at times you simplify and you do not see your answer in the options. What must have happened? It's quite simple, really. What happens is that instead of arranging mine like theirs is, we're having different types of arrangements. If you look at their options, no single one has minus outside the bracket. I mean, I cannot leave minus outside my bracket. And yet, no single one is having both the numbers down as negative. That means what I would do here is that I will take my minus up to the numerator by saying a over x equals to minus into 1 minus m over m plus 1. Now look at my options. Do I have something like m plus 1? Yes. However, that doesn't mean I have minus 1 minus m. So what can I do? Quite simply, one last line. A over x equals, open this bracket, minus times 1 minus 1 minus times minus plus m over m plus 1. This is looking familiar, but it's not exact. I should be having m coming first, positive before negative. So a over x is m, sorry, yes, take this plus m first, m, take this minus 1 second, minus 1 over m plus 1. And that is option A. Now, I would advise you to simply, now that you've seen the final answer, take this video back to the beginning of question 2, and you can now see quite clearly how we're solving. Because most times, it's when you get to the end of the road that you realize why you took a particular route at the beginning. So if you try to go to the beginning now, you shall observe that, first of all, I tried to make A come to my left. And once A was there, I had to divide it by x to get that a over x, which I was asked for. When I got my final answer, it did not appear the same way it was in the options. So I had to adjust my answer to look more like what is in the options. Please note, I did not change my answer. I did tiny bits of adjustments. Where they did not have brackets, I tried to remove my brackets from there and things like that. So it's really very simple. So if you solve a math question for any type of simplification or anything, and the answer is not like that in your options, don't panic. Simply do minute adjustments to make them look more familiar or more identical, and whatever you get will be your answer. With that, let's open another one and try again. This time from 2002, and the question is number 24. We're told to make R the subject of formula in this case, and the formula is x over r plus a equals a over r. Now this one is really simple. First off, I must cross multiply. It's literally what we always do once there's a fraction. We have to make it linear. So x times r is going to be rx equals to a times r plus a. Now, I want to make r subject of formula. In fact, all my arrows should be in the same place. I have this one here already, but there's one arrow here still playing. So I have to bring him to the left. Rx becomes a times r, a times a squared. So now this arrow can come to the left because rx, a arrow comes here, minus ar equals a squared. Now that I have r and r, I can split group them together by factorizing. Arrow comes out, arrow leaves arrow x, just x is there. Arrow leaves a arrow, just a is there. Then now that I have arrow and this bracket, how do you get rid of your bracket? Divide both sides by whatever is in the bracket. So r must be equals to a squared over x minus a. And that is simply option D. So you see, the questions are very, 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 very simple. We'll move on. But we're still using the same method really. This time though, we're going to 2006, question 8. 2006, sorry, question 48. 48, not 8. And in this case, we are told if t equals to 2 pi square root of L over G, make G the subject of formula. Make it G equals something. Now my G is currently trapped under a square root. And we know whenever we have anything trapped under a square root, to start off, we square both sides. This is t squared. Now this 2 is not under the square root. That is going to be affected by the squared. 2 squared is 4. Pi is not under the square root. That should be having pi squared. But this square root, however, simply cancels the square root here. So L and G can simply come out. So this is over 1. And I can cross multiply again because this is my only denominator here. So G times t squared becomes gt squared equals 4 pi squared L. And finally, to get G, I simply divide both sides by t squared. G must be equal to 4 pi squared L over t squared. And that is option B. So you see, the solvings are easy and quite very, very simple. Very, very easy. What can you do to solve? Let's try one more. This one looks quite interesting. This one is from the year 2017, Model 2, question number 40 of your O3 Schools JAMB app. And it simply says, make Q the subject of formula if x cubed plus a cubed plus q squared equals a plus b cubed. Now, this is one of those very interesting questions that you look at and you're like, how can I start? Let's see what we can do. Let's bring everything with q to the left. That means I'll be having q squared plus bq comes here minus bq equals a, take this over there, minus x cubed minus a cube. Now, typically, at this point, we usually factorize. But here's where you notice an issue. If I try to factorize, this becomes q into, take one q out of q squared, and you still have q left. And see, that's a problem, because normally once we do this, everything with q will separate. That simply means I cannot factorize this the typical way. Now, once I begin to observe this, something should flash in my brain and remind me, does this look a little bit interesting? If you've done quadratic equations, then you must have seen something like this. X squared plus 2x plus 5 equals to 0. That's an example of the quadratic equation. And this should be reminding me of 1 because I'm having my letter squared. That's my q squared here. I'm having a situation where I have a constant and that letter, which is my bq here. So I should be having a constant without any letter, which are these. Which means I'm looking at a kind of quadratic equation. And if there's a quadratic equation, all I have to do is arrange this to look more like 1. So I'll be having q squared minus bq minus a plus s cubed plus a cube equals to 0. Or if you prefer, like I do, I'll much rather have positive number coming first here. So that will be plus a cube minus a. Now you see, this looks like a quadratic equation. This x squared is the q squared. This 2x is my bq, while that constant 5 is simply everything here. Now, once you solve a quadratic equation, you are aware you usually get something. If you solve this, you're getting x equals something. So if I solve this quadratic equation, that means automatically I too will get q equals something. But how can I solve a quadratic equation that seems to be made up of just letters and no numbers? The only way to solve this is using the quadratic formula, what some of us like to call the almighty formula. And that formula is that x equals, let's put it down here, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, these a, b, and c are simply coefficients. If you have a quadratic equation, the general form is ax squared plus bx plus c equals to 0. So the a there, this a here, is presenting whatever you have before the variable that is squared. In this my case, this is my variable being squared, and there's no number here. That means a must be 1, the invisible 1 there. B is the number you have before the variable without any power, or the variable to power 1. That means in this case, b should be, funny enough, what is here, which is minus b. So my b in my formula should be minus b. The last but not least, c is simply the one without any letter. So c is the constant, which in this case is this entire sequence of letters, a cube plus s cube minus e. That means once I know this, I can put them into my formula by saying q, which is now what my formula should be showing, will be equal to minus b. But b equals minus b. So minus minus b plus or minus the square root of, again, b squared, or b equals minus b. So minus b squared minus 4 times a. A is 1. So 4 times 1 times c, but c is this expression. So 4 times 1 times a cube plus s cube minus a, all over to A, but A is still 1. So you see, I know that once I begin to solve this, that'll give me my answer. But please, at this point, try not to get too happy solving and forget to look at your options. Because when I look at my options, I realize that in the options, they do not really do much after they put the numbers to the square root. So I should not overdo and forget about that. Because that means all I really have to do now is say Q equals minus times minus is plus. That becomes B plus or minus the square root of minus B all squared. Minus times minus plus B times B, B squared minus 4 times 1 is 4. And this 4 multiplies everything here. If I look at my options, all of them are simply carrying forward the bracket. They did not expand it. So I don't have to either. I can simply say 4 into a cube plus x cube minus a all over 2 times 1 is 2. And if I look at my options now, I realize I have gotten my answer already. This is option A. See? So it appears difficult, but it is not really. All you need to memorize is, if you have any question on that change of square formula, and in that question, the letter you want to become your formula, you have it there in a particular situation squared, and they also have it there not squared. If you're having it, let's say, even if it's p squared equals to 4p plus 3. Once you have something like this, you must go through this method. So anyone at all, once you see that squared there, and you see another one without squared, just know you're going to have to apply the quadratic formula. Do not forget that. If you do, that is when you shall find yourself working hard and it's like you're not getting the answer. So that is that. And we shall simply take one last question and we shall call it a day on this topic of change of subject of formula. Okay, in this case, this question is from 2013 and it is number 11. 2013, number 11. So let's see. This one says if s equals the square root of 4t squared minus 4t plus 4. We have to find s, rather, we have to find t in terms of s. And if you remember the usual thing we do, once there's square root on one side and want to solve, we simply square both sides. Because square always removes square root. That means that s squared equals t squared minus 4t plus 4. Now let's make everything with t remain on one side. And it means that s squared plus 4 comes here. Minus 4 equals t squared minus 4t. Now, I have already spotted the similarity between this question and the last one, which is that if I try to factorize, based on the fact that one of them has squared and the other doesn't, I'll be having t into, remove one t from t squared, you still have t, then minus 4. That means my factorization has not really helped me here. It's supposed to get rid of the other t and leave me having t in only one place. But because it cannot do that, that must mean it's time to go through the quadratic method like we did in number 5. So that simply means that I'm going to need to look at a quadratic equation. I'll be having t squared minus 4t. Then bringing everything here to the right, minus 4 comes first, plus 4 plus s squared comes minus s squared equals 0. So once I have this, what can I simply do? I know that quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. So as before, my a is whatever number is here. Since there's no number there, that must be 1. B is the number that is with just the letter, which is minus 4. and C is the number without letter. Should be this entire expression here, 4 minus x squared. Putting this into my formula, C will be equals to minus B, which becomes minus 4, plus or minus the square root of B squared. Minus 4 squared minus 4 times A is 1, and times C, and C is 4 minus S squared, all over 2A. That is 2 times A, which is 1. So you see, we're making progress. Next up, minus times minus is plus, so that is 4 plus or minus the square root of minus 4 squared is 16 minus 4 times 1 is 4. Let's open this bracket as a whole. 4 times 1, 4. 4 times 4, 16. Then minus 4 times 1, minus 4. Minus 4 times minus s squared. That will be plus 4s squared. All over 2 times 1, 2. Now I already know 16 can subtract 16, right? That's basic math. So that will give me 4 plus or minus 16 minus 16 is 0, so that's gone. Left with 4s squared all over 2. So can I proceed? Yes. Why do I know I can proceed? Because both numbers under my square root can actually get square root for both of them. That becomes 4 plus or minus. What's the square root of 4? Square root of 4 is 2. Square root of s squared is s all over 2. Try not to mistake this with 5. So what can I do? 2 can divide everything here. 2 into 4 is 2 plus or minus, and 2 into 2 is 1. Meaning that my answer is 2 plus or minus s. Now you may realize that that is not in my options, right? Here's where you have to now be sensible. My 2 is definitely positive. That means if I'm to use this plus or minus, I should be having that my answer is t either equal to 2 plus s or t equal to 2 minus s. But in my options, s came first. So if I rewrite, t must be equal to s plus 2 or t equals to minus s plus 2. Now, obviously, minus s plus 2 is not in my options. The only one that actually left with me was that t equals s plus 2. Therefore, this must be my answer, and that is option A. So you see, the only difference between this and the last question was that in this question, I was actually able to manipulate what was within my square root, and so I did. While in the last one, they simply expected me to leave the square root like that because the expression was unsolvable. You see, these are different ways the change of subject to formula question can come, and it's simply a job make yourself familiar with as many as possible. And with that in mind, I'm going to give you a few to work on for yourself. You are free to comment the answer within this channel, and we shall respond to you to confirm if you are right or wrong. So you can try several. Okay, first off, you can start with 2008, and you can try question 12. You can also go to 2009, and you can try question 12 as well. There's also 2010, and try question number 50. Okay, then could also go to 2011 and try question 12. And also one last one, 2012, you can try question 10. So these are the 5 questions I'm counting on you to do. Please do solve them, and you can put your answers as comments on this YouTube, and we shall try to respond to you. So I agree with you, yes, right, or we shall point out mistakes if there are any. And not just these, also go through your O3 Schools JAMB app, search for change of sort of formula, and solve as many as you can. Or even during your mock, you could see different ones. And if there are issues, again, you can comment them beneath this video and we shall respond to you. With this, I want to say thank you very much for watching this video. Remember, you can like this video, you subscribe to this page to see more videos on different subjects where we shall teach you about different topics as you prepare for your JAMB. Remember, get your 3 Schools JAMB app and activate it to enjoy its full functionality. My name is Athanasius. Thank you very much for watching.